Hello students, welcome. This is class 7th science, chapter number 14, electric current and its effects. It is lecture number 10. In this video lecture, we will be covering the first part of summary. So let's start with electricity. What is electricity? Students, electricity is one of the important form of energy. Electricity is used for various purposes like lighting, heating, driving electric equipments, and many more. In our house, we use lot many appliances which work on electricity. The flow of electric energy, or it is also be called as electricity, is called electric current, which is usually measured in amperes, denoted by capital A. The types of materials. Materials are divided into two types based upon their nature. Some are conductors and some are insulators. First of all, let's know about conductors. The materials which allow electricity to pass through them are called conductors. Here in this picture, you can see any metal like copper, aluminium, or steel allows electric current to pass through them. Hence, they all are called conductors. Moving on to insulators. The materials which do not allow electricity to pass through them are called insulators. Here in this diagram, you can see few examples of insulators like plastic, rubber, glass, cloth, and wood. These all materials do not allow electric current to pass through them. Hence, they are used in protective coatings on wires. Now, let us learn about electric circuit. What is an electric circuit? The complete path of wires and electrical components through which electric current flows is called an electric circuit. Basically, it is a closed path in which all the electrical components are attached through wires and electricity or electric current can easily flow through it. In an electric circuit, there is a source of electric current and a switch. Let's look in this diagram. Very easily we can point out that this battery or cell is the source of electric current. This switch allows to close or open the circuit, and the bulb or the light bulb is indicating the electrical appliance. The arrow over here in this diagram represents the direction of flow of electric current. In this diagram, a simple electric circuit is shown. We have here drawn the actual components like bulb, switch, and cell. However, if we look at the circuit diagram, the true pictures do not show the components of the circuit because it is not possible if there are more number of components. Thus, the devices are represented by symbols in a circuit diagram. The same connection of the different components which we just saw, let us represent it with the help of the symbols. You can check here that the bulb is represented with the symbol, the switch with two dots and a line connecting these two dots, and a cell with two terminals, positive and negative. This circuit diagram represents the same setup as we just saw. Let us now learn about some components of electric circuit. First component, the switch or key. The switch that we use in a circuit is called the key. It allows the current to flow after the button is pressed. In general, whenever we need to on any of the appliances, we press the switch. It then allows the current to flow and the appliance starts working. When you press the switch in on position for a bulb, a tube light, or a fan, it starts working because now the current is flowing and the circuit is closed. Students, you can check here in these two diagrams. The first one is indicating an open switch. Hence, the bulb is not glowing even if we have a source of energy. Whereas in the second diagram, when the switch is closed, we can see the bulb is working or glowing. Similarly, when the switch is in off position, the circuit is open and no current flows through it. Once again, pay attention at these pictures. In the first picture, the switch is open, hence the bulb is not glowing. Whereas in the second diagram, the switch is closed and we can see the bulb is glowing. When the switch is off, it means that the current is not flowing through this circuit. After learning about switch, let us learn about the second component, a cell. A cell is used as a source of an electric current. It converts the stored chemical energy into electrical energy. Students, the shape of cells can vary as per the purpose. Some of them are cylindrical and some in button shape. The cylindrical cells can be used in remote and some of the other chemical devices, whereas the button cells can be used in calculators, watches, etc. A cell has positive and negative terminals, and the wire is attached to it. Let's check in these diagrams. A cell has a positive and a negative terminal. It can also be represented symbolically with two vertical lines, one bigger in length, which is representing the positive terminal, the shorter one representing the negative terminal. We can check here that the positive and negative terminals are attached to wires and then to the electronic device. Cell, as we just discussed, is a source of energy. In the same way, the third component, that is battery, is also a source of energy in an electric circuit. Battery is a combination of two or more than two cells which are joined together. As there are two terminals in a cell, same way two terminals are there in the battery. We just read that it is a combination of two or more cells. Hence, the symbol will also have combination of cells to represent the symbol of battery. Here, in this battery, the broader top is the positive terminal and the narrow top is the negative terminal. In a battery, both the terminals appear on the same side. The fourth component is conducting wires. A wire made up of a conducting material is required in the circuit. It is joined for the flow of current in the circuit. It passes current very easily from one part of a circuit to another. You all must have seen these electrical wires. Component 5. Devices or appliances. The appliance or a device which needs the electric current is also attached to the circuit. It could be a bulb or a motor or a heater. In the diagrams below, you can see some of the common household appliances. The next important component of the electrical circuit is ammeter. An ammeter is attached to the electric circuit to measure the amount of current flowing in the circuit. Component 7 is voltmeter. The voltmeter attached to the circuit is used for measuring the voltage or the potential difference in the circuit. Here, the symbol for voltmeter is also shown. Inside the circle, we have written capital V. Let's start the video lecture with our first topic. It is circuit diagram. Circuit diagram. What is circuit diagram? A circuit diagram is a line diagram showing all the components of an electrical circuit by their symbols. The important thing here is, students, the circuit diagrams do not represent the actual components, rather their symbols are used to make the circuit. If you look down here, we can see the symbol of battery, bulb, switch, ammeter and voltmeter. These are the components about which we discussed in our previous video lecture. Adding to it, these arrow in the circuit represents the direction of flow of current. Let's have a look at the symbols of some common electric components. Starting with number 1, electric cell. We already know that in a cell there are two terminals, a positive terminal and a negative terminal. Both these terminals are represented by vertical lines but different in length. The longer line represents the positive terminal and the shorter one represents the negative terminal. Moving on to number 2, electric bulb. An electric bulb is represented by this symbol. Third component, switch. An electric switch can have two positions, one on position and another off position. Let's first check the symbol of switch in on position. Here we can see two dots. However, they are connected. The gap between them is bridged. So, it represents the switch in closed condition. Now, let's talk about switch in off position. Here, the same dots are not fully bridged. You can see there is a gap. So, the circuit is incomplete. Moving on to fifth component, that is battery. In our previous video lecture, we discussed that battery is nothing but a combination of more than two cells. So, if you look carefully at the symbol, you can tell, yes, here different cells are joined. Then we have wires. These are the conducting wires. Hence, they are represented by straight lines. Along with it, we also discussed about ammeter and voltmeter. They are also important component of the electric circuit. An ammeter is symbolically represented as capital A inside a circle. Similarly, a voltmeter is represented with capital V inside a circle. Here we have connected all the required components like bulb, switch and battery to make an electric circuit. However, if this circuit is represented in circuit diagram form, then instead of the real devices, we have used these symbols. For example, for cell, we have used the symbol of cell, same for the bulb and same for the switch. Now, Let's look at some of the conditions which are necessary for electric current to flow in an electric circuit. Condition number 1. The electric circuit should be complete. That is, no part of the circuit such as wires, key or switch should be broken. Number 2, the path should be closed. That is, the switch or key should be in on position. Number 3, each part of the circuit should be a good conductor of electricity. If these parts will be good conductors, then only current can flow through these. A circuit with an open switch is called an open circuit, whereas a circuit with closed switch is called a closed circuit. If you look carefully in these two diagrams, the only difference is of the position of switch. In diagram number 1, the switch is open, hence the circuit is incomplete and the bulb is not glowing. Whereas in the second diagram, the switch is closed. Here, the circuit is complete and we all can observe the bulb is glowing. The next topic is effects of electric current. What all changes happens when electric current passes through electric circuit? Electricity has various types of effects on the objects it passes or flows through. Alright, let's now summarize. It is important to note that not only the filament of the bulb but every wire or device through which the current passes more or less becomes hot due to heating effect of the current. Let's start with the heating effect of electric current. There are many electrical devices which work on the basis of heating effect of electric current. For example, electric heaters, electrical kettles, electric toasters, electronic irons, ovens, geysers, hot plates, hair dryers, etc. Let's have a look at some of the commonly used electrical appliances which work on the heating effect of current. The first one is an electric toaster. Next, a hair dryer. After it, it is electronic kettle. Few other devices like a room heater, an electronic iron, and an immersion rod. These appliances also make use of the heating effect. The amount of heat produced by the element is based on the following factors. Number 1, the material of the element. Number 2, the length of the wire in the element. Number 3, the thickness of the wire in the element. Number 4, the time for which the current flows. All these factors are very important for choosing the type of element for a particular device. Different materials get heated to different extents on passing the electric current through them. This is due to the property of theirs called resistance. The resistance hampers the flow of current through a material. Materials having high resistance produces large amount of heat, whereas materials of low resistance produce very small amount of heat. This property of tungsten and nichrome makes them useful for making filaments of electric bulbs and elements of heating devices respectively. They have the ability of withstand very high temperatures without getting melted. Let's move on to the next topic. It is electric fuse. An electric fuse. In case the electric supply of your room or home is suddenly put out and you realize that all other houses in the neighborhood are getting the electric supply, the first thing that comes in the mind of an elder or an electrician is that the fuse has blown off. Do you know what a fuse is and what is its application? Let us now familiarize ourselves with few basic terms. The first one is fuse. Fuse is a safety device to break the circuit in case of overloading. Students, you must have seen such a component in the mains at your home. This component is called fuse. The next important term is overloading of circuit. Here, overloading means excessive flow of current. When there is more current beyond the desired limit, then we can say we have excessive flow of current in the circuit. The third term is short circuiting. It means a sudden flow of large current due to direct contact of positive, live, and negative neutral wire. Students, while learning about the conducting wires, we learned the types of wires. There, we already discussed about live, neutral, and earth wires. After knowing about what is the construction of fuse, let us know about the applications. Applications means use or the importance or the benefits of fuse. Production of heat in any circuit is a very normal behavior. Sometimes a circuit may get overheated due to overloading. Students, the heating of any electrical component in the circuit is because of the heating effect of electric current. However, at times this overheating is because of the overloading. In this situation, the fuse melts a little before any other part of the circuit could. This is the reason why a fuse is termed as a safety device, because it melts way before the overloading can affect any other part of the circuit. Once it melts, this stops the flow of current and further heating or burning of the circuit is prevented. Let's have a look at the porcelain fuse. This is the ceramic fuse. We can see two metallic terminals, and this wire is made up of either tin or an alloy of tin and copper. We just discussed that if there is an overloading, this wire melts and breaks the circuit without affecting the major damage to the electric components. You can have a look here. This is how the fuse prevent major accidents by breaking the circuit. Thus, a fuse is a safety device for an electric circuit. It makes use of the heating effect of current to save from possible threats of fire. If it do not get break, then the situation can become complicated and lead to a major fire incident. The fuse is rightly said as a safety device. A fuse wire can be easily replaced after getting blown off. But before replacing the fuse wire, the reason for blowing off the fuse must be checked and corrected. The next important topic which we will be covering here is MCB. MCB. What is MCB? Miniature circuit breaker. an automatically operated electrical switch which protects the circuit from damage caused by overloading or short circuiting. It is the MCB, Miniature Circuit Breaker. About this MCB, we just discussed that it also acts as a safety device. When there is any condition like overloading or short circuiting, this switch falls down and automatically it cuts the supply of electric current in the circuit. We just need to lift it up again to make the circuit closed circuit. Students, in this picture, the short circuit is shown. You can see in the single socket, so many wires were attached, and maybe somewhere the live wire get into direct contact with the neutral wire and it results into short circuiting and fire sets up. This picture, on the other hand, represents the overloading of circuit. At times, unknowingly, we plug in so many chargers into one socket, which may lead to the problem of overloading. Hence, it is advised to avoid plugging in so many switches into one socket. That's all for this video lecture. Thank you.